Thank you, Kurt. Good morning, everybody. Yeah, let's continue to keep this informal. If y'all have questions, I think we're doing real good on time this morning, so if anybody's got questions, raise your hand, holler them out, or whatever as I go through. So I made a kind of conscious effort, realizing where I was in the agenda today and kind of the time available, to kind of keep things at a bigger picture level as far as lessons learned. I knew who was preceding me in the last day or so I had Neil talking about the anti-branching, Kurt's talked about the overall program, Will talked a lot about functions and got into a lot of details. So I knew those guys were going to be giving you a lot of detailed information. So I thought maybe as kind of winding down the workshop, we would kind of look, maybe step back and look more at bigger picture lessons learned, and hopefully things each of you can take back to your respective projects. I know we've got some designers here, we've got some clients here, owners, some stakeholders, that type of thing. So hopefully some goals and lessons learned that you each can apply. Just kind of re-saying what I just said. The one I want to start out with is, one approach does not fit all. I think this workshop has been a great example of that, and the swamp project in general has been a great example. It's very innovative in the approach of using a lot of different techniques to really try and get at their overall goals of the program, which are water quality improvement and ecosystem improvement. And again, the past presenters have gone into a lot of different detail on the different techniques that were used. So we had natural channel design that was used in particular on phase 1, some on phase 4, as you just heard as well. The anti-branching design that Neil went over in phase 4. The detention systems, primarily phase 2, where the pond and the dam was put in at the lower end of the project. Had wetland systems like the one that was done in phase 3. Neil talked about some of the aspects of phase 4 that were wetlands as well. And even some traditional, what we call more traditional stormwater BMPs within the watershed as well that Kurt talked about some yesterday. And beyond the data that's been collected here and the results that they've seen, there's a lot of literature out there talking about the benefits from the treatment train effect of where you put multiple practices in place in series and you get good water quality, in particular to the water quality goals. You get to see good improvements there typically. Talk a little bit about natural channel design. One of the things most of my career has been focused on has been stream restoration. And certainly here in North Carolina, it's the preferred stream restoration approach. Some would argue it's the only restoration approach that's really talked about. We've got a number of people here from Virginia. I think Virginia is very similar from my very limited experience, that natural channel design is really what you hear talked about. But I think more and more the restoration community is realizing that is one tool in a larger toolbox. There are a lot of different approaches out there that can be used depending on the scenario that you have and the type of system that you're working in. Again, I think the swamp project's been a great illustration of that. Depending on the type of system you're working on, the type of goals that you're looking at, there's really different ways to kind of skin the cat of how you want to get the results that you're looking for. I think more and more we're realizing too, as maybe as the restoration world is being expanded a bit, and we're not just thinking about single thread perennial channels, the scope is widening now. A lot of core jurisdictions take jurisdiction over ephemeral channels. Do they take jurisdiction on ephemerals in Virginia? They don't go that far, do they? I know West Virginia does, I know Alabama does, I know some of the others we've worked in do as well. So when you start to get up to intermittent and ephemeral channels, you have to start to ask the questions, okay, well, how does natural channel design even apply to that, and this idea of single thread channels and that type of thing. So we're getting into cases where natural channel design in its traditional form may not serve our needs, but some of the approaches that are used as far as going to reference sites, gathering data, I think those are still good concepts that can be applied. They just have to be applied in a new way. I think kind of the status of the science now is, how do we take these different approaches that are out there, the different academic camps that are out there, practitioner camps, and how do we determine what is the right criteria? What's the criteria we can use to decide which of those tools is best for a given scenario? I think over the last, how many people read that article about the Rosgan Wars like a few years ago? Nobody? Ah, we got one person.
Rebecca Long was written the whole book on that.
Yeah, there's some people that have made entire careers over critiquing different approaches. And I think there's been a lot of wasted effort, honestly, on one camp criticizing another. I think each camp, each type of approach that's out there has merits in certain situations. And I think we need to get beyond the infighting and whose approach is better and look at, okay, well, under which criteria is that approach most appropriate? What are things we can learn from that approach and apply to this approach to make it better? I think that's kind of where the community has come to. I'm seeing a lot more talk about collaboration, sharing data, sharing approaches at conferences and meetings like this than I have in past years. So that's kind of exciting from kind of my standpoint. One example, I was going to show you something I have worked on, so got some personal investment in this, I guess. One thing that came up back in about 2006, is that right, Mac? The headwater guidance, 5 and 6. The Wilmington District of the Corps came to the understanding, and I give them a lot of credit too, because I haven't seen this in any other districts yet. In our coastal plain environment, we have a lot of channels that have been dug and channelized through wetlands, through systems like that probably never had single thread channels. Certainly not like they're there now, where they're straight and they've been dug down to the intercept water. The Corps has jurisdiction over those channels now if they exhibit an ordinary high water mark, but they had a realization that, well, the only thing we've got currently that allows people to do mitigation on this, if they have to do mitigation, is natural channel design. So people were going back and trying to do these single thread little channels about that big, and it really didn't make a whole lot of sense, certainly not what was naturally there. So the new guidance was put out saying basically you can restore headwater wetland systems that have wetland function but that flow and would be present in a historic valley feature, and that would allow stream credit. So you're basically allowing stream credits on the mitigation side by doing wetland work. So now that's a mitigation context, but I think this concept can be taken to non-mitigation type projects too. So then the question becomes, okay, well, how do we know when we can apply that guidance from a technical standpoint, and when should we be doing more of a natural channel design? When should we be doing the single thread designs, and when should we be doing more of the braided headwater wetland type of approaches? So this was some data we went out and collected from a number of reference sites in our coastal plain here, and looking at finding as best we could what we felt like represented good headwater reference locations, and looking at the channel forms that we could see there. And we broke it out into 3 different categories. So down here at the bottom, we've got what we call poorly defined systems, and these are wetland systems in a defined valley that definitely exhibit flow, but don't have necessarily well-defined channel bed and banks. May not have them at all, may have them in some places, but not in others. There's really not a defined channel that you could point to. The next category was what we call moderately defined, where there is a definite bed and bank, but the morphology, the dimension parameters of that channel varied quite a bit over the reach, and you couldn't really say, okay, this is a typical cross-section like you would with a single thread. The channel may braid out in some places into 2 or 3 channels. It may come back together for a ways as a single thread, then it may branch back out again. So it had channel form, but there wasn't a consistent form. And then we got into systems where truly were, okay, yes, this is our typical Rosgan reference reach. It's a single thread channel. It meanders through the floodplain. It's got good floodplain connection. It's got very uniform channel features, kind of what you would think about as your traditional reference reach in the natural channel design context. And so in splitting these out, this plot here has drainage area on the X and valley slope on the Y. So you can think of drainage area as sort of a surrogate for amount of water in the system. So the larger the drainage area, the more water you're going to have going through that system or being delivered to that system. Valley slope is sort of a surrogate for energy. So the steeper the valley slope, the faster that water is going to be flowing, therefore more energy to do work and actually cut channels, scour, and do those type of processes. As we sort of stratified them out on this scale by channel form, we saw these nice breaks that developed. So as you get down in this region where you've got low slope and relatively low watershed areas, you really don't get a lot of channel formation. As you start to increase drainage area and increase slope, you get more and more channel definition and channel morphology developing. So what we've done is use this as a guide on several fairly large-scale restoration projects we've done in the coastal plain, where using this tool to kind of help guide us in, okay, this is an appropriate spot to do more like headwater wetlands, braided design. Coming on down the valley, maybe we've got things steepen up a little bit. Sometimes you've got escarpments where the valley slope steepens. Those would be areas where you typically find more single thread. So as I mentioned, that approach has been used on several sites. This is a restored site, the coastal plain of North Carolina. You can kind of see that flowing water coming through there, but not a very well-defined channel like you'd think of in the typical restoration photos. This is a site we're looking at in Alabama, where it's a very large-scale site. It actually starts at the interstream divide up where the ephemeral drainages begin and actually comes on down to about a second or third order channel by the time we get to the end of the property. So on that site, we're going to be dealing with everything from single thread channels that are up to maybe second order streams, all the way up to the watershed divides basically, where we've got ephemeral channels that are really going to have no channel form at all. A lot of wetland features in the watershed, so some of these systems, actually all the systems that we're going to restore are going to have wetland function to them in some context, either associated or adjacent to single thread channels, or perhaps they're just going to be flowing wetlands with no defined channel form as you get further and further up the watershed. So taking some of this data we've developed in North Carolina, taking that tool, finding reference sites down in this region. This is actually the plateau region of Alabama, not the coastal plain. So we're very different geology, geomorphology. But I think the physics in Alabama are going to be the same as the physics in North Carolina. So I think as we gather data from reference sites down there, we can use that type of approach to figure out the restoration that's appropriate to get, again, that highest level of functional restoration. Another pretty extreme example, this is an ephemeral reference site that I think Will may have used in his slides the other day too, but we went out and he was interested in large woody debris measurements on some of these systems. I was more interested in the channel formation, and actually through this system, you can't see it, there actually was some channel form up through there. So in West Virginia, the Corps would claim jurisdiction on that channel. Why do we care about a channel that's maybe 20% slope? We're never going to be working on that. Actually, they do. In West Virginia, where there's mining going on, a lot of times they're actually having to rebuild entire valleys. And without getting political, the way it's been done in the past has been pretty bad. Not a lot of functional uplift. And I think we're looking at ways that they could do that really wouldn't be any more costly than what's being done now, but have significantly more functional uplift. Bringing things back, I got a little off track there with a lot of rural stuff, but bringing things back more to the urban scenario. In the urban context, you're dealing a lot with constraints, and that's a big consideration as well. And this one approach doesn't fit all. A lot of times your constraints may actually drive your approach. Neil's anti-branching design is a great approach as he described, but if you've got a situation with an incised channel and buildings right up to it, probably not going to be able to bring that water back up onto a historic floodplain. There's going to be flooding considerations. So there, you may not be able to get that level of functional lift and water quality improvement. You may have to look more at what I think Will described yesterday, the priority 2 restoration, where you're cutting the floodplain at a lower elevation. You're going to get some functional uplift. You're not probably going to get the same level of uplift as you would where you're bringing it back to a wide historic floodplain, but you can get some uplift there. So It's setting your goals in terms of the constraints and what's realistic and practical for your project. Kurt asked me to talk a little bit about permitting, and these systems are tricky. So a lot of what we've been talking about on Duke's campus here, and a lot of what you'll get into in an urban environment, I think, in a lot of cases, is headwater systems. And on most headwater systems are going to exhibit some of them are going to be stream, and there's going to be wetland mixed in there as well. And the thing that's important to remember is that a stream and a wetland are two very different things in a regulatory context. There's different rules that apply to each. And when you try to gray those lines between what's black and white in a regulatory context, sometimes that can get tricky. It definitely requires you to have better communication with your permitting agencies on what your approaches are going to be. I like to think of permitting as a process that goes in through the entire project. It's not just a step that you get to when you hit 60% design and then you go for 3 months of permitting and then you're done. A lot of these projects, like the ones that were done for Swamp, involve some kind of creative ideas, and it really involved the agencies up front, of talking to them of what was going to be involved and getting their opinions on how that could be done from a permitting standpoint, because they all have their rules. As much as they may love your approach and your idea, they still have to work within the rules of what they're allowed to do. So you have to work with them on how to make that happen. And my last point there on that one is don't get lost in semantics. So I've got a couple of examples there. One was we were doing we had a proposed stormwater BMP site in the mountains here, and it was going to go through a fairly degraded wetland system that was already there. And as soon as the permitting folks saw that you were proposing a stormwater BMP in a wetland, stop, you're done. Can't do that, can't be done. But in talking with them, what we communicated better than we did in our original submittal, and should have had them more involved up front, was that what we were actually proposing to do was actually enhance that area of existing wetland and then do some more, I guess, structural BMP work down below the jurisdictional wetland boundary. So in that sense, once they understood that, they're like, oh, okay, well, yeah, that's okay, because you're enhancing the original wetland that's there. You're not taking any wetland function away, you're actually improving it. You're getting your stormwater functions as well. We're good with that, we can permit that. So don't get lost in semantics of saying, okay, you can't put a stormwater BMP in a wetland. You know, it depends on how you present it and what how you put it in terms that they can permit, I guess. We talked a little bit about this one yesterday. This is the phase 3, which was the wetlands. And the issue that came up on this one, I believe it was Kurt that talked about it yesterday, was this ran into a permitting issue because the existing channel that was there that was highly degraded was considered perennial up to the point of the discharge pipe that leads into this. And so the comment that came back was, well, you can't put a wetland in a jurisdictional stream. You have to maintain a jurisdictional stream. And I think, you know, the design that was done has worked well. I think in today's environment, I think that design may have been done a little bit differently and could have been presented differently. Maybe to incorporate more of a low flow channel, maybe smaller than a typical bankful discharge that wound through that floodplain and provided a lot of floodplain interaction, maybe more so than you would expect in a natural channel design. You know, maybe flooding several times a year more than averaging the 1.5 or something like that you typically hear quoted. I think that could have been done. We've talked about the regenerative design. That was not even in anyone's vocabulary, at least not that we were aware of, back when this project was originally designed. I think something like that could have been proposed as well to get a little better function. Will talked a little bit, actually quite a bit, about goals in his presentation yesterday, particularly from the functional lift standpoint, and I kind of wanted to bring it back up in maybe a bigger picture view. I think it's very important, and most everyone I think would agree, it's very important to have clear goals. But But I can tell you in the literature, it is a common critique of stream restoration that very few projects have defined goals. And I think it probably varies by region around the country, depending on the reason that the restoration work's being done. But I know a lot of the work that's done here does have very clear goals. If it's mitigation driven, that has extremely clear goals. If it's grant driven, the goals have to be actually provided in the grant documentation as what you're going to do and why you're going to do it. But I can tell you as an industry, there is a lot of critique about that. But I think goals are important. It focuses the target. So any of these projects, you have quite a few stakeholders, quite a few people that are involved. I think having clear goals gets everybody aligned because everyone comes into a project with their own perspective of what they're expecting to get out of it. Along those lines, it improves collaboration, which I'll talk about in a little bit. And it, you know, at the base, at the real generic level, it offers the metrics by which you can evaluate whether your project was successful.
So where does a non-government watershed group go to get assistance for developing your goals beyond like a nice, something beyond pretty much non-specific?
Yeah, I'm going to jump ahead a little bit. So it's important, I think, for anybody, whether you're non-government, nonprofit, whoever, to define who your stakeholders are in your project, you know, who's going to be involved, and then develop the goals from that group. And that group kind of sets what they want to achieve with the project. So I think it would fall back to you all on what those goals need to be. Now, again, again, jumping a little bit ahead, I think the regulatory agencies probably need a seat at that table as well. Because ultimately you will, if you're working in jurisdictional water, you will have to have permits. And so you've got to make sure your goals align with what they're going to be able to permit on their side as well. I think there's three problems I've run, I kind of broke out three main ones. Reservations I've run into from people about setting goals. And I think one reason we don't see more goals being set as an industry for restoration. One is the mentality that if I don't set goals, I've got no way to judge that it was a failure. And Will talked about that in his yesterday with the brook trout stream. I thought that was a pretty good story. I think you could also apply the corollary to that or the inverse to that, that if you don't have goals, you really have no way to define success either. So you don't really know if you've achieved what you were setting out to be or setting out to do, which is one of the critiques in the literature. I think it's very important to have those clear goals set, and actually having that up front actually increases your chance of success because you can't hit the target if you can't see the target. The other one I've run into quite a bit is, well, we don't have a monitoring budget, so there's no point in setting goals because we won't have any way to determine if we've met them or not. That's a pretty limited view. I mean, obviously there's been a ton of monitoring done here on the swamp project. That was one of the real purposes of the project was to gather that data. But very few projects we work on in the private sector that you guys work on may have monitoring budgets. Or if it does, like for example, mitigation compliance, it's oriented to a certain goal of defining have you met mitigation criteria. It may have nothing to do with whether you've met water quality criteria and that type of thing. I think you have to make sure your goals are attainable and practical within the constraints of your project. Let me give you an example here I think it illustrates. So let's say nitrogen reduction was one of your goals for your project. And there's I've listed two examples here you could think of. One would be to reduce total nitrogen load to downstream waters by 10, 20%, whatever your number is. That's a very quantitative goal, and that will require a regimented monitoring program. Whenever you talk about reducing loads by a certain amount, that means you're going to have to take samples for concentrations. You're also going to have some methodology of calculating the flows in and the flows out to get to the total load. So that's a very intensive monitoring would be required to determine if you've met that goal. But Neil did a good job of talking about the processes of denitrification and why they're seeing some of the reductions they are in the antibranching. The other way you could say that goal or consider it is to say that we're going to reconnect the stream to its historic floodplain to increase soil saturation and promote the conditions for improved denitrification. That's getting towards the same goal, but that's something you can actually document at the as-built condition. When you can show that your channel geometry intersects that historic flood or your constructed floodplain, whichever, and that you're getting good interaction with that floodplain and that you are raising that water table from what the condition probably was if it was an incised channel. All right, so the other reservation I think people have is they're like, oh, my project's too complex. I've got too many partners involved. Everybody's got their own agenda. We'd never get to consensus. There's just too many goals. We just have a bunch of them out there. I think it's important to prioritize and think of things in terms of primary goals, secondary. You could even go down to tertiary if you wanted to. But I think you have to define what those primary goals are going to be that are an absolute requirement for the project. And then I think it's okay to set secondary goals, that if you hit them, that's going to be great. If it's not going to be considered a failure if you do that. I've got a couple examples. Well, before I get into the examples, as we work more and more across the country, I'm seeing greater and greater emphasis on this idea where there are primary goals that people are doing projects. Maybe it's flood control, maybe it's stability, but more and more I'm seeing clients, owners, municipalities, designers interested in, okay, we can do that, but how can we also get better other functional uplift in terms of what Will was talking about yesterday? How can we get other benefits to the project? And I think part of it's the economy we're in. Everybody's interested in more bang for the buck. Maybe more so than that, beyond regulatory drivers and that type of thing. I think it's that people are seeing others do it. And so when you see another municipality that's stabilizing their streams, getting greenways back, showing improvements in water quality, it kind of makes your projects where you're going out and rip-rapping in concrete and everything kind of look maybe second best now. Those guys are doing it. They're actually doing it for less money. Why don't we look at doing that? So I think there's a lot of data being passed back and forth about what's actually possible out there. And I think it's an exciting time as we push more and more of these boundaries as designers, practitioners, and the folks out doing and implementing the projects and making them happen to see really how far can we push this uplift idea. Okay, here's one of my examples. I went out last year and met with some designers out in California that were doing stream restoration. And I knew before the meeting we were talking very different terms when we talked about restoration. A lot of what I've done is more natural channel design where we're trying to use natural materials, meandering channels, that type of thing. Their community out there is really still more in a traditional mindset of channel work. And so a lot of it is driven by civil engineers. So they do a lot of channel hardening. So this was one of their projects they wanted to show me. And we walked out there and I'm going like, okay. They warned me beforehand. They're like, you're not going to like what you see. You're not going to like it. I was like, well, that's okay. We have different approaches, different goals. And we were looking at the...
It looks like mine,
It does have a little bit of an architectural aspect to it, doesn't it? But these are all Gabion structures that were put in to create this large weir. And there's several of these down the valley for this channel. Designed to the 100-year flow. And obviously created to be quite stable, quite expensive. This is Orange County, California. I actually got the place name wrong down there. So this is stream restoration in the OC. You've heard of like Hollywood and OC. Yeah, this actually discharges into Laguna Beach, very big touristy, high-dollar area. And so we were talking about the approach, and I was telling them, okay, well, things I may have done differently if I had been approaching it, of using more natural materials. And the guy was listening, he was being very nice. He's like, that's all great, but see those houses up there? Each one of those is at least $5 million. We have to have zero chance of failure in this project. And so I never really thought about it in those terms. Their property values are so high, they have to have zero chance of any kind of failure. So that's one reason they engineer them this way. But my point in showing this is they were extremely proud of these wetland areas that they had implemented in between the structures. So you can see there's a long flat area there. This is right after construction. A lot of that vegetation has been planted. They actually can't see it here, but they've actually included some low flow channel areas so that you can have a low base flow coming through there. And they were saying that they actually had to push that with their agencies to let them do that. But they did it from a standpoint of trying to improve water quality and get better filtration during storm flows. So even though they were totally focused on stability, they had this desire to, we can do more than just stability. We can get some water quality improvements too, and we're going to push it a little bit to see if we can do that. Yeah.
Do they call that restoration?
This is what they call restoration, yes.
Permitted up to 27, nationwide 27?
You know, I don't know about that. I don't know if we got into the details of how they permit it. But natural channel design, as we would talk about here, it really hasn't caught on out there. You know, you're dealing in this particular area, very urbanized, very flashy systems. They don't get nearly the rainfall we do, but they get it in 2 or 3 storms, you know, during the year. So you've got these canyons basically that are highly erosive, and when they go in and stabilize it, by God, they stabilize it. Yeah. They actually took me to another I'm running a little long. They actually took me to another project, one very similar to this, is about 10 years old. And it actually, so these gabions do collect sediment, and vegetation does grow up through them. And there actually were quite a few, I would say, natural functions occurring there. They did have a lot of vegetation that had come in between the structures. They had canopy over the system there because it had been there that long. And so, yeah, it was getting some functional uplift from the water quality and ecology side too, I would say. Another extreme example, this is Houston, Texas, and we've been working for the last couple years on working with the flood control districts down there. This is what they call their frontier channel. So in their suburban areas that are sprawling and they're having more and more development, they put in these large conveyance channels to carry the 100+ year event to prevent flooding. It's completely driven by flood control. So you've got all these different pipes that come in, you know, from the adjacent developments, and they will construct this single thread, extremely straight pilot channel down the middle of it to carry the base flow. And so one thing we have been working with them on is new design guidance of when you can incorporate wetland features, when you can incorporate some more natural stream features within these systems. Still have to provide flood control. Can't flood people out. That is their main objective. They're a flood control district, so that is goal number 1. But they are interested in how can we do things better, get better water quality treatment, get better function, and still achieve our main objective. So again, that desire to do more, perhaps with less. So.
There's grass on it, doesn't it?
It is green, but they mow it every 2 or 3 months. Yeah. All right, so real quick, and I'll wrap up quick. Another key point, and I think all of you understand this, but sometimes we forget it. You know, collaboration is critical in these projects, especially with one like Swamp, where there's so many different components, so many different players involved. There's the ones that are listed on the webpage. Really, collaboration with who your stakeholders are and the people that have involvement in the project is critical. Even starting before the project even starts. You know, a lot of these have grant funds involved, so even back to the stage of initially conceptualizing the project and what you're going to do, I think it is important to have good collaboration with the folks that are going to be involved. And I define a stakeholder as anyone that can either help your project along or significantly implement it or impede it if they're not included. I think that's maybe a piece that's overlooked sometimes. Sometimes you have to include your potential troublemakers in order to keep that project moving forward. I think that's easy to forget, but boy, they can really cause problems down the road if you don't include them. So, I talked about the importance of goals. You know, everybody will come to a project with their different perspectives. I think it's important to look for commonality as part of that collaboration effort. You know, look for the goals that everyone can agree to. And typically it's not that hard to do. You just got to understand where people are coming from, and they've got to understand your perspective as well.